To locate points in the plane on the plane, so we use coordinates. Uh, First, we need for that two axes. So let's graph this axis. Is here an y-axis, vertical axis, and an horizontal axis. Okay, that we call x and y. The, the origin, they intersect at the point. We call it the origin, and there is vertical axis is the y-axis. Now, a point in the plane will be located by two numbers, e and b. E, if you consider the projection of your point, vertical projection on the x-axis parallel to y-axis, right, vertical. So the distance or the distance of my point to the y-axis is number is this is the number a. Okay, is exactly my number a or absolute value of a. Okay, so this is exactly the distance. If you look at your projection here, okay, this 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 is a distance, absolute value of a. Okay, and so we put the number a here. Okay, and for b, if you look to the distance, this distance, okay, now this distance, it's exactly the absolute value of b, and we put the number b here. Okay, so so this is how we locate our points. Okay, we consider the two orthogonal projection with respect of the y-axis and x-axis, and read these two numbers a and b. Okay, now let's do an example. Okay, yes, and the two axes divide our plane into four quadrants. Okay, this is quadrant number first quadrant. This is the second. Okay, this is the third one, and this is the fourth quadrant. Okay, quadrant D. Yeah. Now, yes, let's learn how to apply and see how to locate the points. Okay, locate 3 points A with coordinates -2, 0, B with coordinates 1, 1, and C with coordinates 1 and 0. Okay, uh, yes, we can do that. So we can do it on the same graph here. Let's use another color, for example, red one. -2, 0. So the point A, it has, so it's a point that has a distance of 2, okay, from the y-axis, okay, like here. But negative, so since it's negative, so it cannot be here. It must be here. So from 0 to the y-axis, if it's uh, no 0 to the x-axis, 0 to the x-axis, okay, the distance. So it must be on the x-axis, and so my point will be here, -2 and 0. Okay, B is 1 unit from 1 unit from the y-axis. Okay, 1 unit, so it will be somewhere here on the vertical line, and 1 unit from the B, so it will be here. Okay, so 1 unit, 1 unit. My point B is 1, 1, and finally C will be this point, this location. Yes, C 0. 0 from the distance is 0 from the x-axis. That means the point is located on the x-axis. So here are how my 3 points. Okay. Now find another question. Find the middle. Find the middle point, middle of line segment, for example, EB. or let's say, let's take EC of EC. Okay, so the middle point, let's call it M, has coordinates. We add the coordinates of A and C. Okay, so let's say XA plus XB over 2, show that is exactly like that. We can find them. YA plus YC over 2. So finally, we will get here are the coordinates of 8 minus 2 plus 1 over 2 and 0 plus 0 over 2, which is which is minus 1 over 2 and 0. Okay, so minus 1 over 2 is here. So yes, exactly this is what we were expecting. It is the middle point. This is M, which coordinate minus 1 over 2, 0. Okay, it divides the line segment EC into two equal parts, okay, with the same size. What if we were asked now to find the distance, a distance between 2 points? So the distance between 2 points, okay, so is denoted, for example, if we want the distance EB, okay, which is exactly given by the square root of, we show that xb minus, you can make just the difference between the axis plus the difference, the second coordinates, okay, EB, okay, YB minus YA square, okay? And yes, we can here can compute it, have an application, okay. uh, So we will have then 1 minus 1 minus 2 square plus yb, y of b is 1 minus 0 square, which gives us square root of 3 square plus 1 square, which is square root of 10. Okay, and like that we can we can have different questions, check that, for example, show that the uh, triangle EBC is a right triangle. So here we have a simple uh, figure. We can guess where is, we can guess our vertex, where our right triangle is. The right angle is here. Okay, so that will it's enough, it's sufficient to check the Pythagorean theorem. So do I have check the, let's check the Pythagorean theorem. So do we have EB square equal to EC square plus BCB square? Do I have this? Okay. So here this side, I know it's square root of 10 square. Do I have, is it equal to this distance? So if this distance EC, so will be 1, so 1 minus 2 square plus 0 minus 0 square, okay, everything square, plus here is the distance CB also has the coordinates of each point, and so it will be 1 minus 1 square plus 1 minus 0 square, everything square. So finally here I will have, so square root of 3 square plus here square root of 1 square, which is 3 square plus 1 square, okay, and this is 10, which is equal, so yes, the answer is yes, my triangle is ABC is right, a right triangle triangle on at the vertex C. Okay? So this is how we locate the point. We need two vertical, two uh, two perpendicular axes that cross on O, and we locate each point by two numbers that we call coordinates. The plane is divided by the axis into four quadrants, like organized like we saw. We know how to compute the coordinate of middle point of line segment EC and the distance between two points.